We turn now to the subject of the chain rule. Um, Basically, the chain rule is going to fill out our differentiation rules for functions that are formed by combining other functions. We've learned earlier these two rules that I'll put check marks next to here. We learned the product rule that if we have a function that's the product of f and g, then its derivative is fg prime plus f prime g. And of course, we learned the quotient rule that if the function is f over g, then its derivative is gf prime minus fg prime over g squared. The thing that we're missing is what about composite functions? In other words, what about we put one function inside another. So suppose that our function is f of g. What is the derivative of that? And that's the thing that we don't know. That's why I put a question mark there. So this is the question that the chain rule is intended to answer. So if we let h of x equal f of g of x, then h prime of x is f prime of g of x times g prime of x. Or you may find it a little easier to remember in this form, it's f prime of g times g prime. I'll put a dot there. So it's f prime, the g inside of f prime, and then you multiply the whole thing by g prime. This is what's called the chain rule. And it is to composite functions what the product and quotient rule are to product and quotient functions. I guess you could call it the composite rule. They just don't call it that. They call it the chain rule. So let's see how the chain rule works. So let's suppose that h of x is equal to sine of x squared plus 1. Find h prime of x. The thing you have to do when you're looking at a possible chain rule problem is you have to realize that the chain rule is about functions where you have an inner function and an outer function. So this g of x in this case is the inner function, and then f of x is the outer function. You have one function wrapped around another. So what you can see here is that what we have is inside we have x squared plus 1 being inner, and sine x is the outer function. So if I had to write sine x squared plus 1 in the form of f of g of x, what I would say is that f of x equals sine x and g of x is equal to x squared plus 1. Then you can easily see that this combines to say that h of x is equal to f of g of x, because that's equal to the sine, that's the outer function. In other words, we do is we take sine of g of x, and that equals the sine of x squared plus 1. So this is what we call the decomposition of a composite function into its inner and outer parts. So now that we know what f and g are, we can simply write out what all the derivatives are. We know is that f prime of x is equal to cosine x, and g prime of x is equal to 2x. So let's say that we recall the chain rule. H prime of x is equal to f prime of g of x times g prime of x. So that's going to equal f prime is cosine x. Actually, let's do it from the inside. So let's say f prime of g of x, which is x squared plus 1, and then times g prime of x, which is 2x. So since f prime is cosine x, that's going to equal cosine of x squared plus 1 times 2x. So there we go. So that's the derivative of sine x squared plus 1.